when the switch is closed. If an 80 volt supply is supplying power to the circuit, what would be the maximum possible value of the resistance for which the current flows through the circuit? So it's given here that the fuse is rated at 0.8 ampere, which means that the current will continue flowing through the circuit when the current is limited to 0.8 ampere. So according to Ohm's law, current is just equal to the voltage divided by the resistance in ohms. Now take note that the circuit, the current is limited to 0.8 ampere only. So let's take a look at the choices here. The first option will give us voltage, which is 80 volts, divided by 100 ohms. This will give us 0.8 ampere, which is just equal to the rated voltage, and the current will flow through the circuit. This is just exactly equal to this. How about the second one? So 80 volts divided by 90 ohms, and this would give us 0.89 ampere. The next one is 80 volts divided by 80 ohms, and this would give us 1 ampere. And then the last option is 70 ohms, so that would be 80 volts divided by 70 ohms, which is just equal to 1.14 amperes. So among the choices here, only the resistance that is equal to 100 ohms, that would give us 0.8 ampere. The rest are greater than the rated current. So the answer here is 100 ohms. That is the maximum possible value of the resistance for which the current flows through the circuit. What is the total amount of energy if a 12-column charge produces 3 volts? Voltage is defined as 1 joule per column. So that is voltage equals joule per column. That we're given here the charge, which is 12 columns, and voltage. So we now solve for the amount of energy in joules. So that will be joules